Math 3, Module 1, Practice Problems 1.1 through 1.3, the last question, number 7. Again, this would be a great place to go, would be your toolkit notes for the exponential rules and problems that we did. Solving A. First thing I want to check is, do I have the same base? 3 and 3. Yes, I have the same base, so I can right away set my exponents equal. X plus 2 equals 3x minus 4, and then I'm going to solve. So, subtract x. 2 equals 2x minus 4. Add 4 to both sides. That reduces. 6 equals 2x. Divide by 2, and my answer would be x equals 3. In B, first thing, again, don't have matching bases. So I'm going to do a little bit of side work here and split up 64, which would be 2 and 32. I'm intentionally dividing by 2 so that I can get a matching base of 2. 2 and 16, 2 and 8, 2 and 4, 2 and 2. I get 1, 2, 3, 4, 5, 6 2's. So 2 to the x minus 4 would equal 2 to the, since my 64 is in the denominator, it's going to be a negative 1, 2, 3, 4, 5, 6. Then I can set my exponents equal. X minus 4 equals a negative 6, and solve. Add 4. X equals negative 2. In solving C, I think this one is the trickiest of them all, because 243, when I break it down, I can't only get 9, so I have to actually break down both 9 and 243 to get 3's. 3 and 81, 3 and 27, 3 and 9, 3 and 3. So 1, 2, 3, 4, 5's. So 243 can be 3 to the 5th. We know 9 breaks down to be 3 and 3. So I can replace a 9 with 3 squared, but then that's still raised to the 4 to the x. When I raise a power to a power, we learned that this rule means I'm multiplying my exponents. So this is now 3 to the 8th equals 3 to the 5th. Finally, to the point where I have matching bases. So 8x equals 5. Divide by 8, and I would get x equals 5/8. Last problem, D. Got a little squished here, but I want to get matching base. I have 5 here, 125. Breaking that down, 125, if I divide 5, I get 5 and 25, and that's 5 and 5. So this is now 5 to the 3rd to the x plus 2 equals 5 to the 5x minus 4. Raising a power to a power, I'm going to multiply 3 by both the x and the 2. And this is now 5 to the 3x plus 6 equals 5 to the 5x minus 4. And then solving that. 3x plus 6 equals 5x minus 4. I'm running a little bit out of room here, so I'm going to kind of do some combo steps. So subtract my 3x. That would eliminate there. Add 4. Both sides, that eliminates there, and I get 10 equals 2x. Divide by 2, and I would have an answer of x equals 5. That would wrap up all your problems for your review for the Module 1 of Math 3 quiz, sections 1.1 through 1.3.